Algebra 1, Unit 2, Lesson 2, Evaluating Expressions Using the Order of Operations. So the order of operations are to start with any type of grouping symbols, such as parentheses, which is why we put a P. It could include brackets, it can include the absolute value sign. It also includes the fraction bar, the thing that separates the numerator and the denominator. Any type of grouping symbols like that, you have to do inside the parentheses first, starting with those that are innermost first. Then you go to exponents or powers. Then you do multiplication and division at the same time from left to right. So whatever you come to first, if you come to the multiplication first, you do it first. If you come to the division first, you do it first from left to right. And then addition and subtraction are always the last thing that you do again together from left to right. If you come to addition first, you do it first. If you come to subtraction first, you do it first. Now those are the rules. I will also say that since addition and subtraction have to be done last, you can do anything separated by addition and subtraction in the order of operations and then combine them at the end. So you don't have to strictly do everything one by one. You can do more than one thing at a time as long as you are not doing the addition and the subtraction from left to right and you're following the rest of those rules. So it says 3 times 8 minus 5 plus 6 times 2. We have these minus and pluses separating these three parts, so we can do anything in this part, anything in this part, and anything in this part at the same time. So we can do 3 times 8 is 24. We would leave the minus 5 and then put 6 times 2. We would replace that with 12. Then we have to do what? From left to right, we come to the subtraction first, so we have to do it first, and then we're going to add the 12 to get 31. 35 divided by 7 plus 56 divided by 2 plus 6 minus 3. Again, these are separating the parts that we can do. So there's nothing to do here until we've done these things here. So we have 35 divided by 7 is 5, and then 56 divided by 2 is 28, and then we write those other two things down because we haven't done them yet. And then we're going to do from left to right the adding and the subtracting. So we can do all of these together. We know adding can be done in any order. 5 plus 6 is 11, plus 28 is 39, and then we're going to subtract the 3 to give 36. Here we have the quantity 7 plus 6 squared minus 5 times 8 plus 15 divided by 5. So here again are our dividing things. We have a minus and a plus. I need to do everything here first. So the rule is I start inside the parentheses first. I'm going to take 13 first and then square that. Then I'm going to subtract. I'm going to do the 5 times the 8, which is 40, and then add the 15 divided by the 5, which is 3. Then in terms of the order, again, I still have those parts separated. I need to do the squaring first before I can do the adding and subtracting. So I'm going to do 13 squared is 169 minus 40 plus 30. I come to the minus 40 first. I would subtract the 40 and then add 3 to give me 132. Now there are some other ways that you could do this correctly. But again, you're always safe if you follow the order of operations, and I would suggest that's what you do until you're sure that you understand how the order of operation works. 30 plus 50 divided by the quantity of 2 plus 3. There's a plus. We have to do everything here following the order of operations first. So we have 50 divided by, we have this in parentheses. We have to add those first. Then we're going to do the 50 divided by that 2 plus 3, which is 5. 50 divided by 5 is 10. Then we do the 3 plus the 10 is 13. Here we have this dividing, 2 parts inside parentheses, so we need to do this part and this part separately. We have the 5 outside yet. 15 minus 9 is 6. Then we have 3 times the quantity 1 plus 4. What we need to do inside parentheses there first, so that's times 5. So now I have this plus again. I still need to finish these up in terms of the order. 3 times 5 is 15. Then I would add my 6 plus 15 because that's in parentheses, get 21. Then multiply by the 5 is 105. Then we have the quantity 21 plus 3 squared over the quantity 10 minus 4. This fraction bar is also like a separator or a divider, so we have to do everything on the top and everything on the bottom before we can do the division. So on the top we have 21 plus 3 squared. We need to do 21, 3 squared is 9. 10 minus 4 is 6. Then we still have to do everything on the top first, so we have to add those to get 30 divided by 6, would now be 5. If we have an algebraic expression and we're told some values, we're going to substitute those in its place. So this is 2x, which means 2 times x, plus 3 times y squared minus 4 times z. So when you substitute the numbers, you can't just write, when it says x is 2, you can't make that 22. No, 2x means 2 times 2. And then this is 3 times, well, y is 4, so instead of y, I'm going to write the number 4 squared, and then instead of z, I'm going to put 8, so that would be minus 48. Then again, I have the plus and minus dividing them, so I need to do the 2 times 2, which is 4. The 3 times the 4 squared comes first, so that would be 16, and then this one I can do the 4 times the 8 is the 32. But I still need to do the multiplication first, so I multiply, and then I add this, and then subtract this. Another example of that, we have 2x times the quantity y minus x, all divided by the quantity xy plus z. So now I need to substitute this 5 wherever I see the x. I need to put this 8 wherever I see the y, and I need to put this 2 wherever I see the z. Again, we need to do the parentheses first, so that would be 3. Now we have 2 times 5 times 3. All over, the 5 times the 8 needs to be done first. 40 plus 2. We multiply everything on the top to get 30. We add the 2 on the bottom to get 42. Now we can reduce that by dividing this by 6 and this by 6 to get 5/7. Again, now we want to use algebraic expressions in realistic situations. So first we're going to define anything that's unknown. We're going to tell what that variable is. Write the algebraic expression, and then if we're given any values, then we will substitute them and evaluate. So 2 fundraisers were done at TIA, chocolate sales and candle sales. Chocolate bars sold for $1.50 each, while candles sold for $6 each. Ali and Omar each sold some of the items. Write an expression for the amount of money they collected. So there are really 4 different things that we don't know. We don't know how many chocolate bars Ali sold, and we don't know how many candles he sold. We don't know how many chocolate bars Omar sold, and we don't know how many candles he sold. So if we let x and y be the number of chocolate bars Ali sold and the number of candles Ali sold, then for Omar we need 2 more variables, say w and z, the number of chocolate bars and the number of candles that Omar sold. Then how much money would we get? Again, if there are 2 chocolate bars, I would have to multiply each by that $1.50, so there would be $1.50 times 2. If there were 3 chocolate bars, I would multiply by 3. If there were 10 chocolate bars, I would multiply that by 10. So I first have to find the number of chocolate bars, which is now x plus w, and I would take that number of chocolate bars and multiply by $1.50. The same is true for the candles. Since each one sold for 6, I find the total number of candles by adding y and z, and then I multiply that number of candles by the $6. That would be how much money they collected for the candles, and then I need to add them together as the total. Now we're told that Ali sold 1 box of 60 chocolate bars and 10 candles, while Omar sold 2 boxes of chocolate bars and 2 candles. So since there were 60 in each one, Omar sold 2 boxes, so that was 120 plus Ali's 60 meant they sold 180 chocolate bars together, which we need to multiply that $1.50 to get $2.70. And then they sold 10 and 2 candles, so that was 12 candles total times that $6.72. When we add them, we would get $3.42. We have one side of a rectangle that's 2 feet more than 3 times the other. Write expressions for both the perimeter and the area. So one is 2 feet more than 3 times the other. So if x is one side, then the other one is 2 feet more than 3 times the other. So 3 times this one is x, and then we want 2 feet more than that. That would be 3x plus 2. Then the perimeter, we have to add those things together, which you could do as 2 x's and 2 of these 3x plus 2's. That's one way of writing it. And then for the area, you would multiply those 2 together. In future lessons, we will learn how to simplify those expressions.